Okay, this is how to do number 13 on homework A.8. 8, I'm sorry, A.8. This is the one involving the stone that is dropped into a well. Essentially, this entire section over here is explaining to you where this total elapsed time equation comes from and what S and T1, T2 represent. To summarize, what's happening here is they're dropping a stone into a well, and it takes some time for the object to fall. So the first part of this time equation here is T1, where square root S over 4 is the time it takes for the rock to fall. However, it takes a little bit of time for the sound to make it all the way up to you after it hits the water. It has to actually like travel up. And that's the second part of the time component over here. It's saying T2 is S over 1100. So in total, from the time you let go of the rock and drop it down, to the time that you hear when the rock basically landed, that total time is given by T1 plus T2, but we don't really want two variables, so it would be better to write it as one equation. So another way to actually write this that would probably be better is I'll just use T, regular T, to describe the sum, the total time, instead of splitting it up into time 1 and time 2. That's going to be square root S over 4 plus S over 1100. You're actually probably more used to this as like f of s or even f of x, where instead you would write this as x. I think this is a little more familiar, but just for the sake of the problem, I'm going to keep everything as t's and s. So instead of x and y or x and f of x, I'm going to use t and s. Now, without even reading the rest of this question or without even reading any of the details, I'm going to jump straight to what it's asking me. Over here, it's saying I need to find S approximately. It says find the distance to the water surface. Find distance to the water surface. That's going to be my S. If time elapsed is 1 second. So what they're basically telling you is this is your time over here, T for time. S is your distance. It's saying find S when your time is 1. So all I'm going to do is I'm going to take this and set it equal to 1. Now, I'm going to be honest, this is solvable by hand. However, you probably just want to do this by a calculator. So, especially because this is round to the nearest hundredth. So right away, one thing that you can do to sort of cheese your way to an answer is just graph this on Desmos. Unfortunately, Desmos I don't think is smart enough to recognize what variable should be what. So instead of using t and s in Desmos, I'm going to use y and x. So I'm going to use y equals square root x over, what was it, 4, I think? And then it was plus x over this, if I remember right. Yeah, okay. And then I want to do y equals 1 in a separate line, and I want to figure out where these two things cross. And Desmos is smart enough to highlight this point for me over here, and it looks like my answer should be 15.55, just based on the graph alone. So we're expecting our answer to be 15.55. I'm just going to go ahead and add this screenshot into my document. Now, if I wanted to, how could I find this by hand? Because it is possible. How could I find the solution to this? Okay, first off, what I want to do is rewrite this in a more approachable form. I'm not a huge fan of the fact that I'm mixing together square roots and I'm mixing together regular variables. So what I'm going to end up doing is instead making a u substitution. I'm going to say u is equal to square root s. Well, now what this means is everywhere I see an s, I want to change it to, or sorry, everywhere I see a square root s, I want to change it to u. But you'll also notice something else. What if I square both sides of this mini equation that I'm making? Just for the record, I'm inventing this. This is not found in any like textbook. This is not a known formula or anything like that. you just invent this. This is like a little bit of creativity on your part to come up with a substitution. So I just want to point out here that if I have u equals square root s, then if I square both sides, the square and the square root would cancel each other out, and I would actually just have u squared equals s, because the square and the square root, you would cross them off, they disappear. So going back to this equation, what this does is everywhere I see a square root s, I get to change that with u. So this is going to end up being u over 4 instead of square root s over 4. And same thing over here. This tells me s is equal to, skip over the middle part, u squared. And that's going to give me another replacement. So now my equation went from being ugly, it had a square root in it, and it had a regular s. Now this is actually a quadratic. So what I want to do now is push everything to one side and make it actually look like a quadratic. Because right now it's a bit ugly. So first thing I'm going to do is I'm going to change around the order that I add these in. So I'm going to add them in a different order. And then I'm going to move the 1 over to the other side by subtracting. And the other thing I might want to do is, I'm not a huge fan of this divided by 1,100, so I'm going to multiply everything by 1,100. However, if I multiply on the right, or sorry, on the left, it doesn't matter because I'm going to have a 0. But in any case, I'm going to go ahead and do that to everything. Everything is going to get multiplied by 1,100. Now, typically people don't write this step in much detail, but I'm just writing it here just to show you where the numbers come from. 1 times 1,100 is still just 1,100. This 1,100 divided by 1,100 cancels out. And over here, this number simplifies. I believe this is like 200 and something. 1,100 divided by 4. Yeah, it looks like this is 275. So this fraction simplifies to just 275. And then on the left, 0 times this is 0. So just to process what we did, I took a really ugly looking equation that I didn't know how to solve anything for. I made a substitution, and it turns out that this substitution makes my problem solvable. It goes from ugly and unsolvable to a quadratic. And we have a ton of different ways to solve for quadratics. And then all I'm doing from here down is making my quadratic look a little bit more friendly. So this is a nicer form for the quadratic. And at this point, you might be tempted to factor. I don't believe this is factorable. What I would recommend doing at this point, if you wanted to solve it by hand, is to use the quadratic formula. Okay. So, okay. I hope that was fine. If I want to use my quadratic formula, keep in mind I have u1, u2. I have 2 answers for u. And sorry, I don't know why I copy pasted that. I need to do negative b. B in this case is 275 plus or minus square root of b squared. So that's going to be 275 squared minus 4 times a times c, all over 2a, but a in this case is 1. So this right here, this is just me plugging in all of my numbers into the quadratic formula. And at this point, you could simplify. It's going to be quite a headache to simplify this by hand, so I may not recommend doing all of these, but if you're going to do these steps by hand, just do them very carefully. This is going to end up being positive 4400. 275 times 275 is equal to, oh, yikes, 75625. 2 times 1 is 2. So I usually take these a few steps at a time, try to make as few of them as possible, just so I don't make any mistakes. Plus 4400. Okay, so now underneath this ends up being 80025. And I wonder what the square root of that is. Does this come out nicely? square root of, oof, it does not come out nicely, unfortunately. So this one right here, nasty answer. That being said, I think I still will just keep this to a couple digits. So I'll leave this right here. And then at this point, I'm just going to approximate my square root with, let's say, 4 decimal places. Technically, this is not best practice in terms of what you would want to do. Like if you needed to solve something with a lot of precision, but it's going to be fine for here because we only need to answer with 2 decimal places. So this is good enough. Okay, so when I do that, now what I want to do is split this up into 2 answers for you. So I'm going to say my first answer is going to be the positive version. And my second answer, U2, is going to be the negative version. So this one needs a plus, and this one needs a minus. However, stop. At this point, so you'll notice that I'm getting 2 answers here, but we only found 1 answer when we did the graph, right? And the reason for that is one of these answers doesn't actually make any sense in the context of the problem. And that's going to be this one. So this is going to end up being our false friend. The reason is this U right here, this is going to end up being a really big negative number. Think about it. This is negative 275 minus this other number that's almost negative 300. And then I divide it by 2. It's going to be a big negative number. And let's remember what my substitution was. My substitution was U equals square root S. I'm not actually going to be able to get a negative number out of a square root. Square roots like this will only give me a positive answer. That's called the principal square root. So basically, when I try to square root my S, I should be outputting a positive number. So there's no way that this answer is going to work because this is super negative and I'm not going to be able to square root an S value and get a negative number. So my only real answer is actually this one. Let's simplify this a little bit. I'm going to do my simplifying on a calculator. And this gives me 3.9 for, oops, 4, 3, 4, 5, 6, sure. So that is quite a few digits that I kept for the answer. And finally, like I said, I need to go back to my substitution because I just invented U. U doesn't exist in the original problem. I came up with it. So even though I found an answer in terms of U, that doesn't matter. I need to put it back in terms of S. So basically what I said is this thing is supposed to equal square root S. Now I don't want square root S, I want S. So the next thing I have to do is square both sides. So I have to take this number and raise it to the 2nd power. And now finally, any bets on what we're going to get when I try to square this number? Say this number times itself. And I get 15 here. 15.55, just for proof on Google. Okay. So I do actually get S is approximately equal to 15.55. Mine came out to 5508 when I did all this approximation, but that's fine. So you can see why this one is fully intended for you to be done on the calculator. Doing this by hand is kind of a nightmare with all the numbers. But in any case, this is how you find the answer to the dropping a stone into a well question.